you please elaborate?
The figure illustrates the high-level architecture and components of the Faban harness. Controlling a rig is the master. The master contains a web server which facilitates access through the web interface to the Faban harness. It provides all the user interfaces for submitting, managing runs as well as accessing the run results. The log server receives pseudo-real-time logs from all systems in the rig. The master can also host and execute any number of benchmarks. Faban agents run on both the driver systems and the systems under test. SUT. They allow the harness to launch drivers as well as individual commands to start, stop, reconfigure servers as well as collecting system information and statistics valuable for the benchmark run. The master may run on any driver system or on its separate system. It can as well run on any of the SUT systems. Each Faban harness master and therefore each Faban rig has exactly one run queue. The run queue allows submissions of multiple runs, that is, over the weekend or overnight. The harness will execute these runs in a first-in first-out manner, one after the other. Once one run finishes, the next run will be fetched and executed until no more runs are in the queue. No two runs will be executed at the same time to avoid resource contention on the rig. The Faban harness master contains a log server which receives and stores log records from the master itself, agents, and possibly the SUT. This automatically interposes log records from each system in the rig for easy problem diagnostics. The log reader web interface also keeps updating the log records every 10 seconds, allowing the run to be easily monitored. Run results are created immediately after the run starts. These include run status information, system information, statistics output from tools, and the run log. This allows for monitoring the run while running as well as post-analysis of the run results.
The entire benchmark run process and how the components described above fit in is described in the figure. The harness uses the current run configuration file and the submission form to generate the web form for the run. Using the user entered values, it then generates a new run configuration file for this run. The run is then placed on the run queue to be executed by the run daemon. When ready to run, the benchmark class processes the run and, if defined, uses the harness hook. The diagram shows the significant components of the driver. The registry registers all the agents so that the master can find them and distribute the tasks to them. The registry must run on the master machine. The master starts, stops and collects the metrics for each of the benchmark runs. It also provides services to collect runtime metrics, do a benchmark health check, and to cancel the benchmark run prematurely. The agent is the process that actually drives the load. It will create threads as instructed by the master and drive the load for the length of time or number of iterations as instructed by the master. The agent thread is created by the agent to simulate a single user executing an instance of the driver. The driver is a developer-supplied class that describes the workload and contains all the logic defining how to talk to the system under test. It provides a grouping of all conversation scenarios, each of them provided in form of an operation. The benchmark is a grouping of one or more drivers. The benchmark result or metric is an aggregation of the driver metrics and are reported as one final metric. The standard metrics object collects all the common statistics of a benchmark run. Faban provides an extension mechanism which allows a developer to specify custom metrics that may not be covered by the standard ones. The single process driver shines for its simplicity. It can be run using a single Java process which controls the benchmark execution from beginning to end. The registry is not needed for the single process driver. The single process driver is limited to one running driver and one agent in the benchmark, hence single process. Multi-process driver allows components of the benchmark to scale across multiple processes and, typically, across multiple systems. The multi-process driver requires separate starting of all the Faban driver framework processes. To start the multi-process driver, you will need to start the registry, all the agents, and the master. Consequently,